Okay, welcome. Today we are working on the practice test number 4 for math for the SAT. Without further ado, let's get going. Okay, so this is going to be section 3, no calculator. And we have our reference sheet here. If we need that, we will take a look later. Let's go. All right, number 1. Which of the following expressions is equal to 0 for some value of x? Okay, so, well, we can see that if we have an absolute value, it doesn't matter what the absolute value is, it always has to be greater than or equal to 0. So, for all of these right here, it doesn't matter what's inside. They all have something inside plus 1. Okay? And if we want to know when that is equal to 0, well, then we're going to have to subtract 1 from both sides. We're going to get negative 1. Well, we absolutely know that the absolute value is always going to be equal to or greater than 0. So this is impossible. So not only are these not the right answer, it doesn't matter what's inside the absolute value there. Those can't be correct. So it's going to be A. Okay, excellent. Number 2. In the function above, b is a constant. If f of 6 equals 7, what is the value of f of negative 2? There's going to be a lot of questions. Well, there's going to be almost every version of the SAT that I've come across has 1 or 2 questions like this. You need to figure out what the value of b is before you can figure out the value of f of negative 2. Okay, to do that, we're going to take advantage of function notation. We know that f of 6, we put 6 into our function, we know we're going to get 7. So I'm going to put 6 into our function here. And I know this is going to be 7. So I'm just going to replace that with a 7. I'm going to multiply this across. We get 18 over 2 plus b. Well, 18 over 2 is just 9. If I subtract 9 from both sides, I'll get negative 2 equals b. Okay? So negative 2 equals b. That means that my function, f of x, is equal to 3 halves x minus 2. All right, well, now I want to know f of negative 2. So I'm just going to put negative 2 into this function, minus 2. Okay, well, these guys are going to cancel out. I'm just left with the negative. It's going to be negative 3 minus 2. It's going to be negative 5. Okay. Number 3. All right. If xy is the solution to the system of equations above, what is the value of y? Okay, so we just need to solve the system. Okay, this is going to be pretty straightforward. Looks like I can solve for x very easily on the first equation here. I'm just going to multiply both sides by y. I'll get x equals 6y. Now that I know what x equals, I can substitute that back into my second equation, and I'll get, well, as I rewrite this, I'm going to distribute, so that's going to be 4y plus 4, and I know that's going to equal x, which is 6y. All right, subtract 4y from both sides. I get 4 equals 2y, divide by 2, I get y equals 2. Okay. We have here number 4. If f of x equals negative 2x plus 5, what is f of negative 3x? Okay, well, function notation. Wherever we see an x, we're going to put the negative 3x, or minus 3x. So we're going to get f of negative 3x equals, well, we know it's going to be negative 2 times the input, in this case is going to be negative 3x, plus 5. Okay, let's get rid of parentheses. That's going to be 6x plus 5. 6x plus 5b. Okay, number 5. Which of the following is equivalent to the expression above? Okay, well, I'm just gonna simplify this real quick. So we got distribute across the first set of parentheses, distribute that 3 across here. We're going to get 6x plus 3. That's going to be multiplied times 4x plus 1. Okay. Well, now we need to distribute again. Okay, so we're going to do 6x times 4x. That's 24x squared. And then we're going to have 6x times 1, 6x, and 3 times 4x. That's going to be 12x. Okay, so I can already see that I'm going to have a squared term, a linear term, and a constant. Okay, and in fact, if I add these together, I am going to get 18x. So C is my answer. Okay, number 6. Let's get a pen here. All right. If a minus b over b equals 3/7, which of the following also must be true? All right, well, let's, it looks like for the first couple here, they've isolated the a over b. Well, that could be interesting. Let's see what happens. So I'm not sure how this is going to turn out, but we could just try and cross multiply and see what happens. We get a minus b over b equals 3/7. Okay, well, if I cross multiply, I'm going to get 7a minus 7b equals 3b. All right, so that's going to be multiplying these guys and multiplying these guys over here. So at this point, I've got, I'm going to add 7b to both sides. I'm going to get 7a equals 10b. Okay. Divide both sides by 10. I'm going to get 7a over 10 equals b. And then I can divide both sides by b. I'm going to get 7 over 10, or sorry, both sides by a equals b over a. All right, well, 7/10 equals b over a, and that's not one of our answers, but I know that I could take the reciprocal of both sides, and I would end up with 10 over 7 equals a over b. Well, that's just this one right here. Answer B. Okay, 7. Okay. While preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run each week increased by a constant amount. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8 miles, and her longest run in week 16 is a distance of 26 miles, which of the following best describes how the distance of Amelia's run changes between week 4 and week 16 of her training schedule? And it looks like that each one of these answers says that she's increasing by some amount. So let's figure out how much she has to increase her run by each week. We can look at this And we should see that this week 4, 8 miles. Week 16, 26 miles. Those are kind of like coordinate. Those are data points that go together. So we know we have week 4. It's kind of our independent variable. Week 4 goes with 8 miles. It's a coordinate pair. Week 16 goes with 26 miles. It's a coordinate pair. Now, if we want to see the change between those two, well, we're just going to use figure the slope between those 2 points. Change in the output, over the change in the input. Okay. So what is the change in the output? 8 to 26. Well, it's going to be 26 minus 8. Change in the output is 16 minus 4. That's going to be 18 twelfths, or we could simplify that to 3 halves, or 1.5. So each week she's going to increase her distance by 1.5 miles. And if we come down here, we can see that that first one's ½ a mile each week, 2 miles each week, 2 miles every 3 weeks, and the last one is 1.5 miles per week. So we got D. Okay, 8. Which of the following equations represents a line that is parallel to the line with the equation y equals negative 3x plus 4? Well, what do we know about parallel lines? Parallel lines have the same slope. The slope of each line, slope of this line has to be the same as the slope of this line. So we want to pick the equation with a slope of negative 3. Okay, so if we just look at the first one, and we want to write that in slope-intercept form, we want to isolate the y. So we're going to start out with 6x plus 2y equals 15. Subtract 6x from both sides, and then divide everything by 2. We get negative 3x plus, that's going to be 15 halves, or 7.5. And we can see that this slope is negative 3, so that must be our answer. This equation is parallel to the given equation. Okay, number 9. If a equals 2, what is the solution set of the equation above? Okay, well, let's just plug in 2 and see what we get, see what happens. X minus 2 equals x minus 4. Okay, well, to undo this square root, we need to square both sides. We're going to get x minus 4 squared. Okay. That's really just the same as x minus 4 times x minus 4. So like this. So we can expand the right there. It's going to be x times x. And it's going to be x times negative 4, and then x times negative 4 again, right? So x times x, and then x times negative 4, then negative 4 times x, and negative 4 times negative 4. So that's going to be negative 8x, and then plus 16. All right, this is a quadratic. To solve a quadratic equation, you need to set it equal to 0. So I'm going to subtract x from both sides, and then add 2 to both sides. So I'm going to get 0 equals x squared minus 9x plus 18. Okay, so here we can see we have a quadratic. Our leading coefficient is 1. Therefore, we're looking for two numbers that multiply to C and add to B. Okay, well, in this case, that's not too hard. We can see that 3 and 6 multiply to 18. And if they're both negative, they'll add to a negative and they'll multiply to a positive. So we've got x minus 6, x minus 3. Okay, well, if we set both of these factors equal to 0, we'll see that x equals 6 would make the first factor 0, and x equals 3 would make the second factor 0. And here is where you need to be careful, because when you're solving these types of equations, you need to check for extraneous solutions. So if we put x equals 6 into our equation, we will get the square root of 6 minus a, which is 2, equals 6 minus 4. Well, that would be the square root of 4 equals 2. Yeah, that works. Now, if we plug in 3 into our equation, we'll get the square root of 3 minus a, which is 2, equals 3 minus 4. Well, 3 minus 4 is negative 1, and the square root of 1 does not equal negative 1. So 3 is extraneous. Our only solution in this case will be 6, so D is our answer. Okay. 10. If t plus 5 over t minus 5 equals 10, what is the value of t? Okay, so let's just solve the equation here. We've got t plus 5 over t minus 5 equals 10. I'm going to multiply both sides by t minus 5. On the left, that'll undo the denominator, and on the right, I'll get 10t minus 50. Okay. This is a linear equation, so we want to isolate the variable. I'm going to subtract. Let's see. I'm going to subtract t from both sides, and I'm going to add 50. So I'm going to minus t, and I'm going to add 50. Okay, so I'm going to get, and right here, subtract t, so it's going to get 55 equals 9t. Okay, divide by 9, I'm going to get 55 over 9 equals t. And that is our answer, D. Okay, 11. How many ordered pairs satisfy the system of equations above? I suspect this is going to have be a question that's having something to do with the discriminant. And discriminant is part of the quadratic formula that can tell us if there is 1, 0, or 2 solutions for a system. For a quadratic equation. Discriminant is b squared minus 4ac, if you didn't remember, and that'll come into play in a little bit. So we know that we have an equation solved for x and an equation solved for y. I am going to substitute this y in for this y in the first equation. So it's going to look like this. I'm going to get x equals 2 times 2x minus 3 times x plus 9, and then plus 5. Okay, so start by expanding this out. I'm going to get 2 times, well, it's going to be 2x squared, Okay, for 2x times x, and then 2x times 9, that's going to be 18x. And negative 3 times x, that's going to be negative 3x. And negative 3 times 9, that's negative 27. Okay, plus 5 on the end. All right, I'm going to distribute that 2, so I'm going to get 4x squared. Now if I combine these two right here, that's going to be 15x, and then multiply times 2, that's going to be 30x. And then finally, negative 27 times 2 is negative 54, plus 5. So we get x equals 4x squared plus 30x minus 49. And then I'm going to subtract x from both sides, and I will get 0 equals 4x squared plus 29x minus 49. Okay, so if we look at our discriminant, and our discriminant is 0, if our discriminant is 0, then we have one solution. If our discriminant, is greater than 0, then we're going to have two solutions. And if our discriminant is less than 0, we're going to have, 0 solutions, or 0 real solutions. So b squared, that's going to be, look at our discriminant. So we have 29 is b squared minus 4. Well, a is 4, and c is negative 49. Okay, well, we know that's going to be positive. And then this second piece here, that's going to be negative 4 times negative 49. That's also going to be positive. So that means that this whole, piece under here is going to be a positive value. And that means that we're going to have two solutions. So our answer is C. Okay. 12. Ken and Paul each order a sandwich at a restaurant. The price of Ken's sandwich was X dollars, and the price of Paul's sandwich was $1 more than Ken's sandwich. So Ken's sandwich was X dollars, and Paul's was $1 more than Ken's. If Ken and Paul split the cost of the sandwiches evenly and each paid a 20% tip, which of the following expressions represents the amount in dollars each of them paid? Okay, so let's think about this. We know that Ken's was X dollars and Paul's was X plus $1. Okay, and they split the cost, so they're each going to pay half of the total, and then they're going to pay a 20% tip on top of that. So the total bill is going to be the sum, so that's going to be 2x plus 1. Well, then if they're each paying half of that, then I'm going to use A. They're each going to pay half of the total, which is going to be x plus 1/2. It looks like we're in decimals over here, but that's fine. It's going to be x plus 0.5. Okay, and if they each paid a 20% tip on top of their bill, well, it's going to be this their bill, individual bill, times 1.2, because it's greater than 100%, right? They're paying their base, they're paying 100% of their bill plus 20%. So I'm going to multiply this by 1.2. I'm going to get 1.2x plus, well, this is kind of like 12 times 5, which is 60. And then we see that we have 2 decimal places, so it's going to be 0.6. So our answer is C. Okay. 13. The functions f and g defined by f of x equals, highlight that, f of x equals 8x squared minus 2, and g of x equals 8x squared plus 2, negative 8x squared plus 2, are graphed in the xy plane above. The graph of f and g intersect at the points k0 and negative k0. What is the value of k? Well, k is just going to be the intercept of the x-intercepts, yeah, because these are perfect. These are exactly the same. They're just reflected vertically. Okay, and so these intersections right here and right here, I didn't want to use that. I wanted to use that right here and right here, where the equations are going to be equal. So one way to do it is just to find the x-intercepts of one of these functions. I'm going to pick f. I'm going to pick f to find the x-intercepts. So first thing I'm going to do is I'm going to factor, and I'm going to get a 2 equals x squared minus 1. Oops, whoa. 2 times 4x squared minus 1. Okay, and I will see that that is, we want to know where that equals 0 to find the x-intercepts. I can see that that's a difference of squares. That's going to be 2x plus 1, 2x minus 1 equals 0. So these x-intercepts are going to be at where these factors are equal to 0. 2x plus 1 equals 0, and 2x minus 1 equals 0. Well, this first one is going to be 2x equals negative 1, x equals negative 1/2, and this other one is going to be 2x equals 1, x equals 1/2. Okay, so these this k value is going to be at 1/2. Okay, so these intercepts are at 1/2, 0, and negative 1/2, 0. All right. 14. If the expression above is rewritten in the form a plus bi, and a and b are real numbers, what is the value of a? Okay, so this is some division with or a fraction with complex numbers. To get rid of the denominator, what I'm going to do is I'm going to multiply by the conjugate. And the conjugate is just going to be, conjugate of 3 minus 2i is going to be 3 plus 2i. Okay? Now, what you see here is that this is kind of like difference of squares. What happens when I multiply by the conjugate is that I'm going to end up with something squared. Right? So if I have a plus b times a minus b, I'm going to end up with a squared minus b squared. Okay? Because my ab terms are going to cancel out. I'm going to have a positive ab and I'm going to have a negative ab. So this is great, because what I want to do with this I is I want to square it, because that would turn it into a real number, namely negative 1. So I'm going to multiply the top and the bottom by the conjugate of the denominator, which is, well, it's just going to be 3 plus 2i and 3 plus 2i. Okay, so in the numerator, I'm going to have 3 times 8, and then 8 times 2i. So I have 3 times 8 is 3 times 8, let's see, so 24, and then 8 times 2i is 16i, and then I'm going to have negative 3 times 2 and negative 3 times 2i. So, or sorry, negative I times 3, which is negative 3i, and then negative I times 2i. So that's going to be negative 2 times I squared. Well, I squared is negative 1, so negative 2 times negative 1 is positive 2, all over the first term squared minus the second term squared. So that's going to be 4 times I squared, which is going to be it's going to be negative 4, so that's going to be positive 4. Okay. All right. Now we have on the numerator, we're going to have 26 plus 13i over 13. And then we can simplify that, divide all the terms by 13. We're going to get 2 plus I. And A is the constant. So in this case, the constant is 2. So our answer is A, 2. Okay. 15. Oops. 15. In the quadratic equation above, k and p are constants. What is the value of x? What are the solutions for x? Okay. Alright. So I think we're going to need to use the quadratic formula. It looks like all of the solutions here are all kind of in the quadratic formula format. You got something plus minus a square root over a constant. So I'm going to write my quadratic in standard form. Get x squared minus x over, or k over 2 times x minus 2p equals 0. Okay, well, I'd like to get rid of that denominator. I think that would help. So I'm going to multiply everything by 2. I'll get 2x squared minus kx minus 4p equals 0. Alright, well, to use the quadratic formula, we need to identify our a, b, and c. In this case, a equals 2, b equals negative k, and c equals negative 4p. So if we write out our quadratic formula, it's going to be x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so negative b, negative of negative k is just going to be k plus minus the square root of b squared. Well, negative k squared is just going to be k squared. And then minus 4ac. Well, that's going to be 2 times negative 4p. That's going to be negative 8p. So I have negative 4 times negative 8. It's going to be positive 32p. All over 2a, which is going to be 4. Okay? Looks like these are all separated into two fractions. I can do that same thing here. I can separate this into k over 4 plus minus the square root of k squared plus 32p over 4. And it looks like that is one of our solutions. It looks like that's going to be B. Okay, 16. We've got a diagram here, some shampoo on a shelf. Jim has a triangular shelf system that attaches to his shower head. The total height of the system is 18 inches, and there are 3 parallel shelves as shown above. What is the maximum height in inches of a shampoo bottle that can stand upright on the middle shelf? Okay, so I think we're going to use some properties of similar triangles for this. Just straight on. I think that, well, this right here is 18. Okay, so then I'm going to draw a triangle over here. I know that a triangle that's 18 tall, and this side length here, well, that's going to be 6x. Okay, I know that's going to be similar to this triangle. Yeah, and that triangle is going to be, well, that triangle is going to be 5x on the hypotenuse, and I'm just going to use y for the unknown. So let's figure out what that y length is. Okay, so we know that if they're similar, they're also proportional. So 6x is to 18 as 5x is to y. Okay, well, let's see. Cross multiply, we get 6xy equals 90x. So y equals 90x divided by 6x. Well, that's going to be 15. Yeah, because the x's cancel out, and then 90 divided by 6 is 15. So we know that this distance is 15. Therefore, this distance must be 3. Well, if we know this is 3 down here, if we can figure out what this top piece is, then we can subtract both of those from the total of 18, and that'll tell us the height of the bottle. Okay, well, this top triangle is also going to be similar, and that has a hypotenuse of 2x, and let's use maybe z for the height. Okay, so we know that has to be proportional to the other 2 triangles. I'm going to use the first one that we used. So we're going to have 6x is to 18 as 2x is to z. Okay, well, that's going to be cross multiply. 6x times z equals 36x, and then I'm going to divide both sides by 6x, and I'm going to get z equals 6. Okay, excellent. So I know the top is 6, I know the bottom is 3. Well, I know that the total height is 18, so subtract 9 from 18, the max height for the bottle must be 9. Okay, excellent. 17. In the triangle above, the sine of x is 0.6. What is the cosine of y? Okay, I've seen this come up on several versions of the practice test this year, so I advise you. It will behoove you to remember this fact, this trigonometry fact. Let's take a hypothetical triangle here. Let's say A, B, C. So we've got, this is B, this is A, and this is C. Well, the sine of A is going to be opposite over hypotenuse. That's A over C. The cosine of B is going to be adjacent over hypotenuse, which is A over C. Okay, so what this is saying is what this is telling us is that the sine of an angle, is equal to the cosine of its complement. In other words, sine of theta will equal cosine of 90 minus theta. Okay, so in this particular example, we are taking x and y are complements because they are the two angles in a right triangle that are not the right angle, and because of that, sine of one will equal cosine of the other. So the answer to this will be 0.6. Okay. Ooh, there we go. For what real value of x is the equation above true? Okay. So what we got here is a 4 terms, and a lot of times when we're trying to solve equations with 4 terms, it helps to factor by grouping. In this case, I'm going to factor out of the first 2 terms. I'm going to factor out an x squared. I'll be left with x minus 5. And gee, well, I see if I factor out a 2 out of the second terms, a positive 2, I'll be left with x minus 5. Okay, now I can factor out that x minus 5 out of both those terms, and I'll get x minus 5 times x squared plus 2 equals 0. Okay, well, that means that we've got x minus 5 equals 0 and x squared plus 2 equals 0. We'll get x equals 5, and over here we have x squared equals negative 2. And then we take the square root of both sides, we get the square root of negative 2. We're looking for the real values of x that are solutions. We can see that the square root of a negative number is not going to give us real values, so 5 is our only solution. Alright, what we've got here, let's see if I can, there we go. xy is the solution to the system of equations above. What is the value of x? Okay, so I'm solving this system. I want to solve for x, so what I should be thinking about is eliminating the y variable. Okay, because if I eliminate the x, then I'll be solving for y, and I have to plug it back in to solve for x anyways. So let's eliminate the y variable, and I think we'll be Doing well. So if we use elimination, we can multiply the first equation by 3, and we could multiply the second equation by 4, and then we'll get common coefficients on the y terms. So the first equation will be negative 9x plus 12y equals 60. The second equation is going to be 24x plus 12y equals 60. Okay? Now, if we subtract the second equation, 9 minus 24, it's going to be negative, what is that? It's going to be negative 15, negative 15x. Our y terms will cancel out, and 60 minus 60 is 0. So x must equal 0. Okay, we are done. Okay, 20. The mesosphere is the layer of Earth's atmosphere between 50 kilometers and 85 kilometers above Earth's surface. At a distance of 50 kilometers from Earth's surface, the temperature in the mesosphere is negative 5 degrees Celsius. And at a distance of 80 kilometers from the Earth's surface, the temperature in the mesosphere is negative 80 degrees Celsius. For every additional 10 kilometers from the Earth's surface, the temperature in the mesosphere decreases by k degrees Celsius, where k is a constant. What is the value of k? All right, so what they're telling us here is that it's a linear relationship. It's decreasing by k degrees Celsius every 10 kilometers. Okay, so if we know that it's a linear relationship, then finding the average rate of change between any two data points should give us the rate of change, and k is the rate of change. That's what they're saying. K decreases by k. Okay, so our first point, the temperature in the mesosphere is 50 kilometers from Earth's surface. So at 50 kilometers, the temperature is negative 5 degrees Celsius. And at a distance of 80 kilometers, the temperature is negative 80 degrees Celsius. Okay, so all we're doing is finding the slope, essentially, change in y over the change in x. Well, change in y is going to be negative 80 minus negative 5 over 80 minus 50. Okay, so negative 80 minus negative 5, that's going to be negative 75, and 80 minus 50 is going to be 30. Okay, and we're looking for the rate of change over 10 kilometers. Rate of change over 10 kilometers. Well, right now we've got 30 kilometers in our denominator. So we need to figure out what that is when it's 10 kilometers. Should be pretty straightforward here. We see that if we divide the bottom by 3, we'll get 10. So if we divide the top by 3, we should get our solution. That'll be negative 25. So k equals negative 25. However, we need to be careful here because it's saying that the mesosphere temperature decreases by k. All right, so it doesn't decrease by negative 25, right? Negative 25 is the value that of change. It decreases by strictly just 25. So you would answer 25 on this problem. All right, section 4. This is the calculator section. Here is our reference sheet. If we need that, we can come back and take a look at that later. Number one, the monthly membership fee for an online television and movie service is $9.80. The cost of viewing television shows online is included in the membership fee, but there's an additional fee of $1.50 to rent each movie. Okay. For 1 month, Jill's membership and movie rental fee was $12.80. How many movies did she rent? Okay, so what we've got here is a linear relationship. We got $9 is the base, $9.80 is the base fee, plus it's going to cost $1.50 per movie, and we know that she spent $12.80. So if we subtract $1.90 from both sides, we'll get 3. And if we divide both sides by $1.50, we'll get 2. She rented 2 movies. All right. One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Donald can currently type 180 words per minute and believes that with practice he can increase his typing speed by 5 words per minute each month. Which of the following represents the number of words per minute that Donald believes he will be able to type M months from now? Okay, so we should recognize that this is going to be a linear relationship. So the output equals the rate of change times the input plus our starting value. And in this case, our starting value is 180 words per minute. Okay, so that'll be our B value, and our rate of change is 5 words per minute per month. Okay, so if we start with 180, or sorry, if we have a rate of change of 5 words per month, and we start at 180 words, that should give us our equation. So we got C would be our solution. Okay, number 3. If a 3-pound pizza is sliced in half and each half is sliced into thirds, what is the weight in ounces of each of the slices? Okay, so pound is 16 ounces. Pound is 16 ounces. And we have a 3-pound pizza. So that's going to be 3 times 16. 3 times 10 is 30, 3 times 6 is 18, so it's going to be a 48-ounce pizza. If we slice it in half, we can divide by 2 or multiply by a half, okay? And then we're going to slice that into thirds. We can divide by 3 or multiply by a third, or multiply by a third, okay? And this will give us the weight in ounces of each slice. Okay, so I'm going to divide here by 2. I'll get 24 on top, 1 on bottom. I'm going to divide here by 3, divide here by 3. I'm going to get 8 on top and 1 on bottom. Multiply through, I'm going to get 8 over 1, which is just 8 ounces per slice. Okay, so we got Nick surveyed a random sample of freshmen of the freshman class of his high school to determine whether the fall festival should be held in October or November. Of the 90 students surveyed, 25.6 preferred October. Based on this information, about how many students in the entire 225-person class would be expected to prefer having the fall festival in October? Okay, well, 25.6, that's 25%. That's a quarter, all right? 25.6% roughly equals 1/4. Okay, so I'm just going to do 1/4 of 250, or sorry, 225. A fourth of that is going to be, well, a fourth of 200. Fourth of 200. 200 is 50, and a fourth of, fourth of 25 roughly equals 6.25. So I would say 56.25 people. Okay, well, that's going to be pretty darn close to 60. Another way to think about this, since this is the calculator section, is that you have 225 people, and you multiply that by 25.6%. You've got to write it as a decimal, so it's 0.256. I'm going to pull up my calculator here, and we're going to see that 225 times 0.256, let's close that, equals 57.6. Okay, so 57.6, 56.25, we're still talking about 60. The density of an object is equal to the mass of the object divided by the volume of the object. What is the volume in milliliters of an object with a mass of 24 grams and a density of 3 grams per milliliter? Okay, so the mass is, the density is equal to the mass divided by the volume. Okay, so the mass of this object is 24 or 24 grams, and the density is 3 grams per milliliter. So the density should be 24 grams divided by 3 milliliters, so 24 grams per milliliter. So we will have, 8 grams per milliliter. Last week, Raul worked 11 more hours than Angelica. If they worked a combined total of 59 hours, how many hours did Angelica work last week? Okay, so Raul equals Angelica plus 11. Okay, and we know that the total equals Raul plus Angelica, and that's 59 hours. So that's going to be Raul, which is A plus Angelica, plus Angelica, which is A. And then we have 59. Actually, I'm going to subtract 11 from both sides. So I'll get 48 equals Angelica times 2. Divide by 2, 24 equals the number of hours that Angelica worked. Okay, we got movies with greatest ticket sales in 2012. Table above represents 50 movies that had the greatest ticket sales in 2012, categorized by movie type and Motion Picture Association of America rating. What proportion of the movies are comedies with a PG-13 rating? Okay, so let's think about this. the proportion that we're talking about a part out of a whole. So let's look at the total number of videos. Oops. Total number of videos is 50, and we're looking for comedies with a PG-13 rating. So comedies with a PG-13 rating, that's going to be this guy. So it's going to be 4. Oops. It's going to be 4 out of 50, or 2/25. Alright, what do we got here? Line L in the XY plane contains points from each of the quadrants 2, 3, and 4, but no points from quadrant 1. Which of the following must be true? Okay, well, let's draw a sketch. If the line is in these 3 quadrants, it has to be something like that. Okay, the slope of line is undefined. Slope of the line is 0. Slope is positive or slope is negative. Clearly it's going to be negative slope. All right, that's the big one. All right, we've got the number of registered voters in the United States in 2012 in thousands. The table above shows the number of registered voters in 2012 in thousands in 4 graphic regions and 5 age groups. Based on the table, if a registered voter who was 18 to 44 years old in 2012 is chosen at random, which of the following is closest to the probability that the registered voter was from the Midwest region? Okay, so 18 to 44, that's going to be all of these guys, and we want to know, so it's going to be, the total is going to be all of those, and we're looking for just the people from the Midwest region, so just these out of that total. Well, I'm going to go to my calculator. I'm just going to add up 14,766 plus 47,896. Okay, so it's going to be a total of 62,662, and we want to know the proportion that are from the Midwest. Well, that's going to be 3,453 plus 11,237. It's going to be 14,690. Okay. Now I'm just going to divide. I'm going to get a decimal, what that proportion is, and I'll see that. Okay. So 14,690 divided by 62,662 is going to be approximately 0.234. Okay. All right. Well, that's a decimal. That is the probability that a voter in that range will be from the Midwest, and that's closest to B. Okay. Let's see if we can get this nice and big here. Okay. Gestation period versus life expectancy. Okay. A curator at a wildlife society created the scatter plot above to examine the relationship between the gestation period and life expectancy of 10 species of animals. All right, so 10. What is the life expectancy in terms of the animal that has the longest gestation period? All right, well, the animal that has the longest gestation period is this animal. And the life expectancy of that animal is, looks like 3. And that is 3 years. Okay. Number 11. Of the labeled points, which represents the animal for which the ratio of life expectancy to gestation period is the greatest? Okay, so if we want the ratio of life expectancy to gestation period to be the greatest, that's life expectancy is on the y-axis and gestation is on the x-axis. So we want to have a larger y value, okay, longer life expectancy and lower gestation period. Well, if we look at our points here, we've got these over here have a very large gestation period. They have a slightly higher life expectancy, but the gestation period is way over on the x-axis. So I'm going to say A for my answer to this. Okay, now you can go in and check pretty quickly these values, right? So if we look at A, where it's going to be it looks like 7, I guess, 7 right here. And the A is going to be 7 over, and that looks like 22. B is going to be, looks like 8 over 44. C is going to be 8 over 50, and D is going to be, looks like 10 over 10, well, I guess that'd be 51, but maybe 51, 50, something like that. Okay, and we just have to, we can see that A is clearly bigger than B, so B is not going to be it. A is also going to be bigger than C, and D as well. D is like 1/5. Okay, so A. All right, 12. In the xy plane, the graph of the function f has an x-intercept at -3 and -1 and 1. Which of the following could define f? Okay, so that means we have a -3, -1, and 1. Okay, so this must be a well, if we have 3 x-intercepts, it has to at least be degree 3. It could be a greater degree than 3, but that's the least. Okay, so what are the factors associated with these intercepts? This is -3. That's going to have a factor associated with it of x plus 3. This is -1 is going to have a factor associated with x plus 1, and +1 would have a factor of x minus 1. So these 3 factors have to show up in our polynomial, and we see that they don't show up here. This one has x minus 3, that's not x plus 3, and down here we don't have an x minus 1. So C is going to be our answer. Okay, 13. The population of mosquitoes in a swamp is estimated over the course of 20 weeks, as shown in the table. Which of the following best describes the relationship between time and the estimated population of mosquitoes during the 20 weeks? Okay, so the relationship, well, let's start with, is it linear? If it's a linear relationship, that means that for every constant change in the input, which it looks like the constant change is by five weeks, that we would have a constant change in the output. And it does not look like that's the case. The first 5 weeks we increase by 900. On the second 5 weeks we increase by 1,000. So it's not linear. It's not increasing linearly, and it's not decreasing. So it can't be decreasing linearly. And if we jump down to the last one here, it's not decaying, right? It's growing. The population is increasing, so it can't be decay. It's going to be exponential growth. All right, let's get this a little bit bigger here. Okay, the expression above gives the amount of money in dollars generated in a year by a $1,000 deposit in a bank account that pays an annual interest of R% compounded monthly. Which of the following expressions shows how much additional money is generated in an interest rate at an interest rate of 5% than at an interest rate of 3%? Okay, so if we're talking about the money, the extra money generated, we want to have, there's going to be a certain amount of money that's generated by the 5%. So we'll call that A, right? And that's going to be more than the money generated by the 3%. Oops, by the 3% interest rate, and we'll call that B. And if we want to know how much more, then we need to subtract. Okay, so we need to subtract the interest earned at 3% from the interest earned at 5%, and it looks like the only possible solution is down here at the bottom. Okay, which of the following scatter plots shows a relationship that is appropriately modeled with the equation y equals ax to the b, where a is positive and b is negative? Okay, so if a is positive, let's see, if a is positive, let's see, and b is negative, well, negative exponent, that means it's gonna be a over x to the b, yeah? That means that as x increases, the value of this expression is going to decrease. So we should be decreasing at an exponential rate. So let's say b. That looks like it models that, right? So it looks like that. A looks like it's decreasing, but it's linear. C seems to be increasing, and there's like no correlation in D. Okay, Mr. Martinson is building a concrete patio in his backyard and deciding where to buy the materials and rent the tools needed for the project. The table below shows the materials cost and daily rental costs for 3 different stores. The total cost, Y, for the building materials and renting the tools in terms of the number of days, X, is given by Y equals M plus W plus K times X, which is the number of days. Okay. Alright. 16. For what number of days, X, will the total cost of buying materials and renting tools from store B be less than or equal to the total cost of buying materials and renting tools from store A. All right, well, that's pretty straightforward. Buying materials and renting tools from B. So buying materials and renting tools from store B, that's going to be M. M is 600 for B. 600 for B, so 600. W is 25 for store B, so it's going to be plus 25, and then we've got K for store B is 80, so plus 80 times K. All right. Now for store A, the M is going to be 750. I'm going to give a little bit of room here. 750, and the W for store A is 15. It's going to be 15, and the K for store A is 65, and times X. All right, so if we simplify our top equation here, we get 600 plus 105x. If we simplify our bottom equation, it's going to be 750 plus 7080x. Okay, and we want to know when B is less than or equal to A. All right, so let's copy these values down here. B is 600 plus 105x, and we want to know when that is less than or equal to A, which is 750 plus 80x. Okay, so I am going to subtract 600 from both sides. I'll be left with 105x is less than or equal to 150 plus 80x. All right. Now, if I subtract 80x from both sides, I'll get 25 25x is less than or equal to 150. Okay, if I divide both sides by 25, I'll see that x is less than or equal to 6. Okay, and that is my solution right there. Okay, now moving on. Okay, same situation here for 17. Now, if the relationship between the cost y of buying the materials and renting the tools from store C and the number of days x from which the tools are rented is graphed in xy plane, what does the slope of the line represent? Okay, so I'm only going to use quadrant 1 because we're talking about rental days, right? Can't go negative. So if we graph this relationship, for C, M for C is 700. W is 20, and K is 70. Okay, so 700 plus 90x. Okay, so it's going to look something like this. All right. Well, 700 is the cost for the materials. That's kind of a sunk cost, right? The only other value here is 90x, which is telling us the slope of the line based on the number of days that the rental lasts. So the slope of this line is 90. That means it costs $90 per day to rent the tools. So if we go down look at our answers, A says the total cost of the project. No, not that. The total cost of the materials. No, that would be the 700. Total daily cost of the project. Well, total daily cost, I guess that would be the total cost divided by the number of days. That doesn't really make sense for this situation. D, the total daily rental cost. Total daily rental cost, and yeah, I think that's gonna be our solution. Okay, 18. Jim has identical drinking glasses, each in the shape of a right circular cylinder with internal diameter of 3 inches. He pours milk from a gallon jug into each glass until it's full. If the height of milk in each glass is about 6 inches, what is the largest number of full milk glasses that he can pour from 1 gallon of milk? There are 231 cubic inches in a gallon. Okay, well, let's figure out how many cubic inches are in one of these glasses. The volume for a cylinder is going to be the area of the base, which is pi r squared times the height. Okay, the diameter is 3, so that means that the radius is going to be 1.5. Okay, and the height is going to be filled to 6 inches. Okay, so I am going to pull up my calculator here, and I'm just going to do 1.5 times 1.5. That gives me 2.25. Well, it's going to be 6 times 2.25 pi. And that is going to be 13.5 pi is the volume for each of these glasses. And we know that we have a total of 231 cubic inches, and we want to know how many of these glasses we can get out of that. Well, we just have to divide by 13.5 pi. So we get 223 divided by 13.5 times pi. 13.5 times pi, and we see that, oops, multiplied, I should be divided by, we see that we get about 5.44 glasses. So how many full glasses can we pour? Well, we can't pour 6, but we can pour 5. We'll have a little bit of milk left over. Okay. So 19. If 3p minus 2 is greater than 1, what is the least possible value of 3p plus 2? Okay, so we have 3p minus 2 is greater than or equal to 1, or sorry, 3p minus 2, and we want to think, well, what are we going to have? What about if we have 3p plus 2? Well, all we're doing is adding 4 to this expression. So we're adding 4 to both sides. Nothing's going to change for inequality. So we're going to say that it has to be greater than or equal to 5. So the least value is 5. Okay, let's see if we can. Okay. 20. The mass of living organisms in a lake is defined to be the biomass of the lake. If the biomass in a lake doubles each year, which of the following graphs could model the biomass in the lake as a function of time? Okay, so if something is doubling each year, then there'll be twice as much as there was last year. So let's just look at these graphs. Here, we started with 0, and then there's the biomass is 1, and then the biomass is 2. That's increasing by 1 each year. It's not increasing, it's not doubling each year. Okay, what about the next one? We were at 1, and then a year later we're at like 1.5, and a year later and this is not really even a function. This is I'm not sure, this definitely does not double each year. Okay, what about here? We've got we start at 0.5, then we go to 1, then we go to 2. Gee, that sure looks like it's doubling each year. And then the last one is just a constant. That's not increasing at all. Our answer is C. Okay. It's going to be for 21 and 22. Renewable energy consumption. The bar graph above shows renewable energy consumption in quadrillions of British thermal units in the United States. By energy source for several energy sources in the years 2000 2010. In a scatter plot of this data, where renewable energy consumption in the year 2000 is plotted along the x-axis, okay, plotted along the x-axis, yeah, okay, and renewable energy consumption in the year 2010 is plotted along the y-axis for each of the given energy sources. How many data points would be above the line y equals x? Okay, well, the line y equals x is a just a line, looks like this, with a slope of 1. It starts at the origin. And if we're graphing year 2000 on the x and 2000 on the 2010 on the y-axis, then we're really looking for every point on this line. Every point on this line, x is equal to y. For a point to be above this line, y must have to be greater than x. So up here, every point in this part of the graph, y has to be greater than x. And every point down here, y has to be less than x. Okay, so, and we want to know how many points how many points would be above the line. Okay, so we want to know how many points is y greater than x? Well, y is 2010. So we really want to know, where is the 2010 data greater than the 2000 data? Okay, well, let's just go along here and count it out. 2010 is in the light gray. So it looks like for biofuels, 2010 is greater than 2000. Geothermal, just slightly, 2010 is greater than 2000. And for wind, 2010 is greater than 2000. So we're going to say that 3 points would lie above that line, y equals x. Okay, what do we get here? Of the following, which best approximates the percent decrease in consumption of wood power in the United States from 2000 to 2010? Okay, so we want to know wood power in 2000. It looked like it was right up here at 2.25, and in 2010 we're down here at 2. Okay, so we'll go to 2. So the decrease is 0.25. 0.25 is the part. 0.25 out of the original. So 0.25 out of 2.25. Well, we can divide both by 0.25, or 25 hundredths. We'll get 1 out of, it goes in 9 times. 9 times, so 1/9. And 1/9, 1 divided by 9 is going to be 0.11111. Converted into a decimal is going to be 11%. Okay, 23. The tables below give the distribution of high temperatures in degrees Fahrenheit for City A and City B over the same 21 days in March. Which of the following is true about the data shown for these 21 days? Okay, so all these answers are referring to the standard deviation. Standard deviation is the what's the average deviation from the mean of the data. So the average of the data, and then are the rest of the data points close to that average, or are the data points more spread out? The larger the standard deviation, the more spread out the data. Smaller the standard deviation, the tighter, the more closely grouped the data is. So let's just take a look and see if we can just figure this out by visual inspection here. Both these tables have the same max and the same min, and they have the same intervals too. So the first table, City A, has a lot of data kind of right around here, yeah, up towards the upper end. City B, well, it kind of spaces out pretty evenly over the whole range. So I'm going to say, just from visual inspection, it's clear that City A has a smaller standard deviation than City B. So let's look at some of our answers here. The standard deviations and temperatures in City A is larger. No, standard deviation in A is lower. The standard deviation of temperatures in City B is larger. That sure looks like it. Let's read the rest. The standard deviation of temperatures in City A is the same. No, they're clearly not the same. And D, the standard deviation of temperatures in these cities cannot be calculated with the data provided. Okay, so the standard deviation could be calculated with the data provided. We didn't calculate it. We just took more of a conceptual understanding and applied that. But our answer is going to be B. Okay, what do we got here? In the circle above, segment AB is a diameter. If the length of arc ADB is 8 pi, what is the length of the radius of the circle? ADB. Well, ADB arc ADB, that's a semicircle. That's half the circumference. So then we could say that the circumference for this circle would be 16 pi. Okay. All right. Well, we know that the formula for circumference equals pi 2 pi times radius, 2 pi r. Okay, so you can kind of think of this as a system of equations. I guess it is. But we're going to just do substitution. We're going to put 16 pi in for our circumference, and we want to solve for our radius. Okay, we can divide both sides by 2 pi. We'll see that our radius has to equal 8. All right, what do we have here? The polynomials f of x and g of x are defined above. Which of the following polynomials is divisible by 2x plus 3? Okay, let's see. I think it'd be easiest. I can see that the f is not fully factored. I think it'd be easier to work with it if it wasn't fully factored. I can factor out a 2x. Okay, I'd be left with just x squared plus 3x plus 2. Okay, well, that says something right there. Okay, so now we know that f of x is really just 2x times g of x. Okay, well, I think that helps. So let's see. All right. So let's take a look at the first expression. Well, that's going to be f of x plus g of x. That's 2x g of x plus g of x. This is A. Well, that's just going to be 2x plus 1 times g of x. Okay. Well, 2x plus 3 is not a factor of this guy, and g of x factors into, let's see how g of x factors. Two numbers that multiply 2 and add to 3, it's going to be x plus 1 and x plus 2. Okay, well, 2x plus 3 is not a factor of g of x either, so A can't be our solution. How about B? B is going to be f of x. Well, f of x is 2x g of x plus 3 times g of x. Okay, well, if I factor out g of x, I'll be left with 2x plus 3 times g of x. 2x plus 3 is clearly a factor of 2x plus 3, so B is our solution. 26. Let x and y be numbers such that negative x is less than x and x is less than y. Which of the following must be true? The absolute value of x must be less than y. X must be greater than 0, or y must be greater than 0. So let's make a little model to think about this. I'm just going to use a number line. If I know that y is greater than x, and that negative of y is less than x, well, in between negative y and positive y, there must be a 0, right? So x is going to be somewhere in between this range. Okay, so the absolute value of x is less than y. Let's think about that. If x is positive, right? Let's say it's right here. The absolute value of that is, well, necessarily less than y. If y is negative, let's say way over here, the absolute value of that is just going to be back at this original positive value, and yes, that is less than y. So the absolute value of x, yeah, that has to be less than y. What about the next one? X is greater than 1. Well, not necessarily. I mean, x could be here, right? Sure, x could be here, it could be greater than 1, or it could be less than 1, either way. So say no to that one. And y is greater than 0. Well, so we're going to say that, yeah, y does need to be greater than 0, as we can see from our graph here. Yeah, so we're going to say y is greater than 0. So our solution for this would be 1 and 3 only. That's going to be C. Okay, blow this up a little bit. Oh, that didn't work. Let's try that again. There we go. The relative housing cost for a U.S. city is defined to be a ratio of the average housing cost for the city to the national average housing cost, expressed as a %. And that is what we have here. We have the relative housing cost on the y-axis and the population density on the x-axis. The scatter plot above shows the relative housing cost and the population density for several large U.S. cities in the year 2005. The line of best fit is also shown and has an equation of 0.0125x plus 61. Which of the following best explains how the number 61 in the equation relates to the scatter plot? Well, this is just a linear equation. What? Y equals mx plus b. Remember that m is the slope, b is the y-intercept. 61 is going to be the y-intercept right here. Okay, let's highlight that. It's going to be this y-intercept. All right, so A, in 2005, let's see. Yeah, in 2005, the lowest housing cost in the United States was $61 per month. Well, 61. If the y-axis was the housing cost in dollars per month, that might be true, but it's not. The vertical axis is percent of the national cost, national average cost. So A is not going to be a solution. B, In 2005, the lowest housing cost in the United States was about 61% of the highest housing cost. No, this is talking about percent relative to the national average. Relative to the national average, not the highest housing cost. Okay, let's see. In 2005, even in cities with low population densities, housing costs were never below 61% of the national average. That is not going to be accurate. This scatter plot only shows data from several large cities, in the year 2005. So it's very possible that there is a city that doesn't show up on this scatter plot that may have may be below 61%. After all, a scatter plot is not a perfect representation of every data point. It's just a model that shows you the approximate trend in the data. So I'm going to say no on that point as well. And then on the next one, D, in 2005, even in cities with low population densities, housing costs were likely, that's the key word there, likely at least 61% of the national average. And yes, I am going to say D for our final answer. Okay, 28. What we have here is, we have a function. Which of the following is equivalent form to the function f above with a minimum value of f, function above in which the minimum value of f appears as a constant or a coefficient? Okay, well, I think it'd be easiest just to figure out what the minimum value of f is. We know that a parabola will have its vertex at the x value that's the average of the two x-intercepts. So if we know the x-intercepts, in this case we do, this intercept is going to be at -6 and this intercept is going to be at +4, based on the factored form of the function. So we add those up, we get -2. So the x-intercept must be at x equals -1. So to find the value of the function at x equals -1, we just need to put -1 into our equation. So f of -1 equals -1 plus 6 times -1 minus 4. That's going to be 5, and then times -5. So -25 is the minimum value of our function, and that shows up in D as a constant. Alright, 29. If x is the average arithmetic mean of m and 9, y is the average of 2m and 15, and z is the average of 3m and 18. What is the average of x, y, and z in terms of m? Okay, so let's see. X is the average of m and 9. That means m plus 9 divided by 2 equals x. Y is the average of 2m and 15. That is 2m plus 15 divided by 2. Z is the average of 3m plus 18 divided by 2. All right, so we want to know the average of x, y, and z in terms of m. Well, I know that x is going to be okay, so I'm just going to add, sorry, took me a second there. I'm going to add these up and divide by 3. So if I add them all up, I'm going to get, well, I've got 1m here, 2m here, and 3m here. That's a total of 6m. I've got 9, 15, that's 24. 24 plus 8, well, 20 plus 10, or sorry, plus 18. 20 plus 10, 24 plus 10 is 34. And then 4 plus 10 plus 8 is 12, so that's going to be 42. So that's the sum, right, over 2. That is the sum of those three values. And I want to take the average of them. So I'm going to, I already added them up, I'm going to divide by 3 or multiply by 1/3. Now when I multiply by 1/3, the numerator is going to be, oops, let's get, fix that, will be 6m plus 42 divided by 6. Divide the top and the bottom by 6. I'm going to get m plus 7. M plus 7 will be my solution. All right. 30. The function f of x is graphed in the xy plane above. If k is a constant such that the equation of f of x equals k has 3 real solutions, which of the following could be a value of k? Well, 3 real solutions just means that the function is going to equal that value at 3 places. So one place that the function equals the same output in 3 places would be here. So we see that at, I don't know, somewhere around -1, somewhere around 0.2 maybe, and somewhere around 0.6 for x. For the input, the output will be equal to 3. So we can see that f of -1 equals -3, f of I don't know, 0.2 equals -3, and f of 1.6 equals -3. Okay, so we have 3 real solutions when the y value is, or the output is -3. Okay, so that's going to be one of the possibilities. We see that when the output is 2, yeah, there's just one solution. When the output is 0, there's just one solution. And when the output is -2, there's just one solution. So D is our answer. Okay. 31. A partially filled balloon contains 600 gallons of water. A pool, sorry. 600 gallons of water. A hose is turned on and the water flows into the pool at a rate of 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? Okay, well we start out with 600 gallons plus every minute we're adding 8 gallons per minute, and that's going to equal our total gallons in the pool. So if we want to know after 70 minutes, we're just going to plug 70 into our function here, and we will get 600 plus 8 times 7 is 56. Add a 0, and that is going to equal 1160. All right, the normal systolic blood pressure P in milliliters of mercury for an adult male X years old can be modeled by the equation P equals X plus 220 over 2. According to the model, for every increase in 1 year in age, by how many milliliters of mercury will a normal systolic blood pressure for an adult male increase? All right, well, if we could write this in the form of y equals mx plus b, m would be the increase per year, or x, per an increase in your x, which is years. So I'm just going to take my function here, and I'm going to divide every term by 2. But instead of doing x on 2, I'm going to write that as a coefficient. So 1/2 x plus 110. Okay, and we can see that every increase in 1 year will correlate to an increase of 1/2 a milliliter of mercury. Okay, the PES, I'm not sure, a Roman measure of length is approximately equal to 11.65 inches. It is also equivalent to 16 smaller Roman units called digits. Based on these relationships, 75 Roman digits is equivalent to how many feet to the nearest hundredth? Okay, well, we know that a PES is 16 digits, so we can write that 16 digits is equal to 11.65 inches. And if we have 75 digits, how many groups of 16 do we have? Well, we've got 75 divided by 16. Okay, well, that's going to be, pull up my calculator here. I got 75 divided by 16. It's going to be equal to 4.6. I'm just going to round it to the 8. So we got 4.688. Okay. All right. So that's how many groups of digits we have. Each digit is worth 11.65. So we will have 11.65 inches times 4.688. 4.688 times 11.65. We're going to have 54.62 inches. All right, and we want to know how many feet that is. Well, that's inches, so we need to divide our inches by 12, and we will see that we get approximately, rounded to the nearest hundredth, 4.55 feet. Okay, in a study of bat migration habits, 240 male bats and 160 female bats have been tagged. If 100 more female bats are tagged, how many more male bats must be tagged so that 3/5 of the total number of bats in the study are male? Okay, so if we have, let's see, currently there are 240 male bats and 160 female bats. So there's currently 400 bats tagged. Now 100 more female bats are going to be tagged, so that'll be a total of 500. There will be 500 bats, okay? And of those 500 bats, we know that of those 500 bats, there are 240 male bats. But that is clearly not 3/5, right? The male bats to total bats is something like 12/25. So we want to tag more male bats. Okay, well then we need to tag more male bats. We don't know how many we're going to tag, but we're going to tag X number of bats. Well, if we tag X number of more male bats, the total population of tagged bats will also increase. Okay, well, we want this to equal 3/5. Okay, so we just have a simple proportion here, and we can cross multiply. What we'll end up with is 5 times 240 plus x should equal 3 times 500 plus x. Okay, so let's see if I can, oops, oh, didn't want to do that. Okay, so much for that. All right, if I distribute this, I'm going to get 500 times, or 5 times 240. Well, it's going to be 1,000 plus 200 is 1,100 plus 5x equals, and this is going to be 1,500 plus 3x. Okay, I'm going to subtract 3x from both sides. Oops, subtract 3x, and I'm going to subtract 1,200 from both sides. I'm going to end up with 2x equals 300. Okay, well, I just have to divide both sides by 2, and I'll see that the number of bats, the number of male bats that we have to tag in addition to what is already tagged, are 150. The dynamic pressure Q generated by a fluid moving with velocity v can be found by using the formula above, where N is the constant density of the fluid. An aeronautical engineer uses the formula to find the dynamic pressure of a fluid moving with velocity v and the same fluid moving with velocity 1.5 v. What is the ratio of the dynamic pressure of the faster fluid to the dynamic pressure of the slower fluid? Okay, so let's see. We've got V. V is the velocity of the fluid, and for the first, the velocity of the fluid is v. For the second, the velocity is 1.5 v. Okay, well, we are squaring v. So, and we want to know the ratio of the dynamic pressure. Well, the dynamic pressure is Q. Okay, well, we want to know then Q of the slower velocity versus Q of the higher velocity. Okay, so it's the faster velocity to the slower velocity. Okay, so we're going to have 1/2 N and 1.5 v squared to 1/2 NV squared. Okay. All right. So if we simplify this, we're going to get this 1/2 can cancel out, this n can cancel out, and then we'll be left with 1.5 squared. Well, 15 squared is 225. We'll have 2 decimal places, so it'll be 2.25. That's not very nice there. Let's say. So 15 squared is 225, and we have 2 decimal places, so it'll be 2.25 v squared over v squared. The v squareds cancel out, and we see that the ratio of the faster fluid to the slower fluid is 2.25. All right, for 36. In the figure above, the circle has centers O and has radius 10. If the length of arc AB, shown in bold, is between 5 and 6, what is the possible integer value of x? Okay, well let's start by calculating what the total circumference is. We know the radius is 10, therefore we know that 2 pi r is the circumference, therefore the circumference in this case is going to equal 2 times 10 times pi, which is 20 pi. Okay, now we know that the central angle is going to be proportional to the arc length relative to the circumference and relative to 360. So if the arc is let's say 5, that's the minimum out of 20 pi, and the central angle out of 360 degrees. Well, to solve this, we'll multiply both sides by 360 and get, let's see, 5 on my calculator here. 5 times 360 is 1800. 1800 over 20 pi equals x. Okay, so 1800 divided by 20 pi equals, okay, so that's going to be 28.64. So we know that that's the minimum value of x. Okay, well, what's the maximum value of x? The maximum value of x would just be 6 out of 20 pi equals the max angle out of 360. And then again, we'll just multiply 6 times 360, get 2160 over 20 pi equals x, and 2160 divided by 20 pi equals 34 point, let's round it, 38 equals x. So it looks like the minimum the angle could be is, well, it has to be greater than this, right? Because it can't be lower than that. That's the minimum. It would be 29, and the maximum would be 34, because you can't go over 34.38. And then any number in between 30, 31, 32, or 33, or 34. Any of those would be acceptable. Okay, last couple problems here. We got the stock price of one share in a certain company is worth $360 today. A stock analyst believes that the stock will lose 28% of its value each week for the next 3 weeks. The analyst uses the equation V equals 360 times R to the T to model the value V of the stock after T weeks. What value should the analyst use for R? Okay, well, if we're going to be decreasing, losing 28%, then we're going to be, we start at 100% each year. If it's the same amount each year, we should multiply by 100%, or 1, right? Now, if you're decreasing, you need to decrease that 100% by whatever percent we're talking about. So it'll be 100% decreased by 28. Okay, well, that'd be 100% decreased by 28%. That's going to be 72%. So each year, the value will be 72% of what it was the previous year. So R, the rate that we're multiplying by, should be 72%. Okay, but we need to use a decimal, and the decimal needs to be less than 1 because we're decreasing. So R must equal 0.72, or 72 hundredths. Okay. All right. 638. To the nearest dollar, what does the analyst believe the value of the stock will be at the end of 3 weeks? Okay. So we know that we're doing V of 3. Okay. The value after 3 weeks is 360. Remember that our R value is 72 hundredths, and our T, time, is going to be 3. Okay, so we are going to have 360 times 0.72 raised to the third. I'm going to round that to the hundredth. 0.37. Okay, and I'm going to multiply that by 360. So the value of the stock after 3 weeks should be 134, and we are to the nearest dollar, 134.36. So to the nearest dollar, that's going to be $134.